Okay, we have a position of a cougar modeled by this function here. If you're confused about what s is, typically in calculus we replace d with s because we're going to use the Leibniz notation for rate of change. So if it was y, it's dy over dx for rate of change, the instantaneous rate of change y with respect to x. You can see that if you use d, we will get dd over dt. Okay, so this is not something that we really want. So typically it's replaced with s instead of d. Okay, so having said that, let's go on and answer the first one. Find the velocity and acceleration at time t. So velocity is the rate of change of the position with respect to time. So let's differentiate this. We get 3t squared minus 6 2t. So this is velocity as a function of time. Acceleration is dv over dt. Okay, so our second derivative of the position function. So we get 3 times by 2t minus 12. Okay, that's part A. Okay, when is the cougar moving toward the origin and when is it moving away? Okay, so there's two scenarios. Okay, so if the cougar here's the origin. If cougar is already positioned far away, so a positive distance away from the origin, we need to have a negative velocity to be moving. So in other words, if s is positive, right, velocity needs to be negative, then we're moving towards the origin. Okay, this is towards. Okay, or if s is negative, so we're here, then the velocity needs to be positive to be moving towards the origin. So here the velocity needs to be positive. So there's two scenarios where we can be moving towards the origin. For away, it's backwards, right? So if the position is positive, so to the right here of the origin, then the velocity needs to be positive. If it's negative, the velocity needs to be negative as well. Okay, so let's figure out when is the position positive. So let's factor out t, and we get t squared minus 6t plus 9. Okay, when is it positive? Okay, this is always right positive or equal to 0. So it's positive when t is positive, right? And when t is negative, the position is going to be negative. How about the velocity? Let's factor out 3. So this can be interpreted as a parabola with roots at 1 and 3. Okay. So it's okay when t is in between 1 and 3, it's negative. Okay, it's negative. And when t, so this velocity is negative. If t is less than 1 or when t is greater than 3, velocity is positive. Okay, so this is negative. Okay, so negative, we're looking for two negatives here. Okay, so 1 to 3 is negative when t is greater than 0. So in this entire time interval, right, both s, okay, we're in this category. When s is positive, okay, s is positive and v is negative. So this is when we're moving towards. Okay, so that's it for this case, right? So when it's negative right here, velocity needs to be negative as well. So do you see how they don't overlap at all, right? If you have 1 to 3 and this is less than 0, it doesn't overlap at all. So this is the only time, okay, it's the only time when the cougar is moving towards the origin. How about away? So let's consider this case. When it's negative, the velocity needs to be positive. So there's no overlap. When it's negative, t is less than 0, and it does not overlap with 1 to 3. So it's this exact same situation. Okay, so this situation does not happen. So okay, let's consider this one now. It's positive. So we're talking about this. When time is positive, we want the velocity to be positive. So that's overlapping with this, right? So if you have greater than 0, and we have 1 and 3, less than 1 and greater than 3. So here's the overlap. So when t is 0, between 0 and 1, or when t is greater than 3, it's moving away. Okay, away from the origin. Okay, lastly, when it's negative, does it overlap with when velocity is negative? No, it doesn't overlap at all, right? Between 1 to 3, less than 0, no overlap. So this is when it's moving away. This is when it's moving towards. Okay, so when is a Cougar speeding up and when is it slowing down? Okay. So for part C, speeding up, that's referring to acceleration. Okay. So this is also a little bit complicated. We have to consider the velocity. The question is the velocity positive or velocity negative? If the velocity is positive and the acceleration is positive, okay, here, so velocity is positive, and we have acceleration is also positive. There's two cases, acceleration could be negative, then it's speeding up. Okay, so we can say it's speeding up. Okay, but if acceleration is negative, of course it's speeding down. But here, if you're moving backwards and your acceleration is positive, we're actually slowing down. If it's negative, you want the acceleration to be more negative so that it's speeding up. So there's two times where it can be, okay, speeding up. Okay, so let's consider when is the velocity positive. So we already found out velocity is positive when time, from here, it's right here, right here, right? Less than 1 and greater than 3. Okay, so that's when it's positive. Now, acceleration is positive. Let's go up back, acceleration here. When t is greater than 2. Okay, so we have to intersect these two. Okay, so you can see it's when greater than. This means when t is greater than 3, okay, it's speeding up. Okay, let's consider this now. Okay, so velocity is negative when t is between 1 and 3. Okay, and acceleration is negative when t is less than 2. So this is 1, 3. Here's 2. So we're talking about only when t is between 1 and 2. So when t is between 1 and 2, we're also speeding up. Okay, when is it slowing down? Well, all the other times. So therefore, it's slowing down at when t is less than 1 and 1 to 2, so, or when t is between 2 to 3. Okay. Okay, now we want to graph everything, put all this together. Rough sketch. So here's a factor version of the position function. For the first 4 seconds. So let's do this. So this intersects at 0 and 3. Okay, 3 is a double root. Like that. This is a position function. S and T. Okay, and then this is a parabola. It's got roots at 1 and 3. Okay, it's just gonna look like this. And lastly, this has y-intercept of -12. So way down here, -12, and slope of 6. So it's going to intersect at 2 and go right up. Okay, there it is.